Today's topic is I2C registers. In I2C register, first of all, I will talk about RCGC I2C. RCGC I2C is used for choosing the particulars I2C, I2C zeros, or I2C 1, or I2C 2, or I2C 3. And you can do so by giving some values to this RCGC I2C. Suppose if you give the value 0x02, 2 in hexadecimal is 0010. So if you give this value is 0010, 0010, you have put 1 here. So you set this bit, that means you have chosen I2C 1. So you can use this I2C 1 in your code. The I2C MSA registers. The I2C MSA register is only used for storing the address of the slab device. The address of the slab device is a 7-bit, and so we will use the bit 1 to 7. And this RS 0-bit is used for other conditions like checking whether we are receiving from the slab device or transmitting to the slab device. So I2C MCS register is used for storing the address of the slab device. I2C MCR register. I2C MCR register is used for making a particular device a master, so that you can use that master in your data transmission process of I2C. And you can do so by making the D4 bit set to 1. The D4 bit is master function enables. By setting it to 1 of this I2C MCR register, you are making a particular device as the master, so that you can use that master in your I2C data transmission process. So what does this so this register I2C MCR is only used to set a particular device as a master by setting this D4 bit to 1. In most of the code you will use this register only for that. And then I2C MDR registers. I2C MDR register is used for storing the data that you want to use in your transmissions. As the data bit format of I2C contains of 8-bit, we are using 0 to 7-bit of these registers. So I2C MDR register is only used for storing the data you want to use for transmissions. I2C MCS registers. There are two registers of the same name, I2C MCS. Here is also I2C MCS, but it functions differently. One is used for write as write control registers, and another one is used as read control registers. Write control registers means I2C when used as write control register means it is used. Write means transmitting or sending. So during sending or transmitting process of data from master to slab, this register is used. And then in reading, reading means receiving data from the slab device. You are using this I2C MCS as a read control registers. The read control register is also used in other stuff like checking after the I2C MCS started the transmission process, it need to check. During the transmission, after starting of the transmission process, it need to check the bus is how long the bus is going to be busy. That means you are checking, means you are reading the bus level, how long the bus is going to be busy. Okay, so but you can how long the bus is going to be busy means after some time the bus will stop, that is transmission will finish. So you are going to wait, right? Everybody waits how long when it is going to finish, everybody waits for that. Because of that, it is checking the bus status. So checking means reading the status of the bus. And this I2C MCS can do the reading with this read control registers only. So this I2C MCS used as read control register will be used for checking the bus status. While during the transmission or sending or writing of the data from master to the slave device, that is transmitting or sending the data from the master to the slave device. This I2C MCS, it is when used as a write control register, it has this much of bit. This bit can be accessed by the programmer to be used in their code or program. The others bit are reserved. So this bit, the first bit is called run, and it is used to set up everything in the process so that the start conditions can be met. And then this one is start of the transmissions, stop of the transmissions, acknowledgement. This one is acknowledgement. Acknowledgement is rising of the SDA lines from high to pulling of the SDA lines from high to low when in the 9 clock cycles, representing notifying it as acknowledge. That means it is ready to receive data sent by the master, and it will so it will be received by the slave device, the receiving device. If it can also make the SDA lines not remain pull high, representing it is negative acknowledgement or doesn't want to acknowledge, or neg, representing that notifying that it doesn't want to receive the data. And then HS, this is high speed. High speed means rate of data sending kilobytes per second. And this one is high speed. There are adjust mode like standard mode and other mode. And then I2C MCS. I2C MCS, when used as read control register, it has this much of bit: the busy bit, error bit, address, acknowledge. This. And this busy bit means the bus is idle. The bus is idle in the sense means it is the transmission is going on, and the bus status is cannot be used by another master. Error is the address or data is being not acknowledged. Address acknowledged when it is set to 1, the address is acknowledged, and so the receiving device can start receiving the data sent by the master. The die is also like that. The receiving device is the line being pulled low, stating that it is acknowledged and the die can be received. But here the condition is that this happens when address acknowledged means the die is not started to receive. Okay. And then our blast bit. Our blast bit means checking the level of the bus. The high level of the bus during transmission, low level of the bus during receiving time. So these are the conditions. It shows that the transmission process is going on properly. The idle means the master is in another process and cannot be requested to be do new transmissions by the other select device. The busy bit means the bus is busy, and how long it will be busy. How long it will be busy means after some time when this bit is low, then the transmission will be complete. The clock 2 means the clock is counting whether it has raised to 0. If it doesn't raise to 0, the new transmission process cannot start, or restart condition by the same master cannot start, all those stuff. The birthright. The birthright is an interesting topic where master can a master can write continuously on the memory location of the select device by giving only the first memory location address of the select device. Because at this process, the I2C device will internally increment the memory address continuously until a stop condition is being detected. The birth rate. The birth rate is also another interesting topic where it will read continuously from the memory locations of the select device by giving only the first address by giving the address of the first memory locations. This first memory location address has to be sent by the master in the bus. So here also the I2C device will internally increment the address of the memory locations of those of the memory locations in the that in the select device. So birth rate, how the birth rate will do is the master initiate the start condition. Start condition is started, and then the select address is been sent in the I2C MSA register from bit 1 to 7, and the bit 0 is sent as 0 bit, so that 0 represents right, so that the address is right, and select a particular select device of this address. And then the first memory location address is sent because the birth rate says it should send a first memory location. And then the select address is again sent, and with one bit indicating that the